Hello friends, today we will learn about compilation of a VHDL program on Quartus 211. Open Quartus 211. After opening the Quartus 211, a new window will appear in front of us. Click on create a new project. So once we click on create a new project, another window will come. Click on next. Then we need to specify the destination. The destination can be a desktop or can be any other folder. So here I am creating a new folder on the desktop. I wanted to test program for AND gate, so I'll create a new folder with the name as AND gate. After creating the folder AND gate, I need to choose that AND gate. Now select a folder. Okay, once we select a folder, we need to give name to the project, so I'll give the same name as a project name as AND gate. So next, now we need to choose the device on which we are synthesizing it. The device we are using here is Max 3000A. We need to filter out that Max 3000A with a PLCC package with a 44 pin count and a speed grid of 64 microcells. Speed grid of 10 and 64 microcells. Then click on finish. After selecting the device, now we need to create a new file. So we'll say create a new file that will have VHDL file. So create a VHDL file. We have to save this VHDL file in the same destination. So we'll say that file save as, then we'll give the same name with the destination as AND gate. So AND gate VHDL file we have created. Now we need to write a program. The program will have three sections. The library declaration first, comments, the library declaration. After the library declaration, there will be the entity. The entity name and your file name should be the same. So entity, here we have named it as AND gate, and below that the architecture. The architecture will also indicate about the entity. So we'll save it. Now we can compile the program. After saving it, click on compilation icon. So clicking on that icon will initiate the compilation process. The compilation process may take few minutes. In between, I'll tell you about Quartus 211. For Quartus 211, we need to use separate software for simulation. We will be using Altera's University Program Simulator for simulating this particular AND gate program. And after the simulation, we will synthesize on the Max 3000A device. So the progress of simulation, the progress of compilation can be viewed here. The progress of compilation is in front of you. Once the compilation is done, a pop-up window will appear in front of you indicating a message where the compilation was successful or have some errors. If it has some errors, you need to go and rectify those, and again need to save and compile it. So the chain will continue till compilation is successful. See, you can see the progress now up to 75%. We have done with it. Now it's done. It don't have any errors. You can see that compilation is successful. So we'll say OK. Once we say with OK, we need to view the hardware of it. The hardware can be viewed in Netlist viewer. So then click on Netlist viewer and we'll say RTL viewer. Once we say RTL viewer, a hardware will come in front of us. As we know that we wanted to make a AND gate. So here you can see the AND gate. Thank you. After compilation, the next is for simulation. We'll go for Altera University Program Simulator. If you click it on, new window will appear in front of us. We need to open the project. Click on File and then Open Project. We have to choose a project. So we wanted to simulate AND gate. We will say AND gate, open, and open the AND gate. Okay, so once we said open the AND gate, we will open a QPF file. Now we need to generate new simulation file. Now we'll say file, generate new simulation file. For new simulation file, we need to select input and output pins. Before that, we will save it. We will save it in the same location. So we'll say desktop. In the desktop, we will go into AND gate and we'll save the file. The file name will have extension as vector waveform file, VWF. So we'll give the name as same, AND gate, and save. Now we need to find out the input and output pins. For that, we'll go into edit, input finder. So we'll say node finder. New window will appear. We'll go with the list and we'll select all A, B and C and we'll say OK. We have defined A and B as an input our AND gate program and C as output. So both A and B has been shown as a lower level and output C with don't care. So we need to choose a waveform. We'll select a clock of 100 and a clock of 500 nanosecond, rather a 300 nanosecond. So we'll say 100 nanosecond and a 300 nanosecond, two inputs we are giving. We'll save those things. Now we need to assign simulation settings. We'll go into simulation setting. We will choose functional and we need to even see that where we are seeing the saving the output. So we'll browse it. We have saved it in a desktop AND gate and that waveform extension AND gate with VWF file. So our output will be saved in that thing. We'll say OK. Now we can run for a simulation. So there are two simulations, one with the waveform we will go. Now we will say start simulations. Again the simulation will take few minutes. You can use any another simulator with a little bit change. It will function in the same manner. So here we are using Altera's University Program Simulator. The simulator, once the simulation has been done, it will again generate a pop-up window. It will say generate netlist was successful. We have to click it on OK. Then again a pop-up will come. So simulation was successful. We'll say OK on that. Now you can see that the file is read only and cannot be edited, and we can see that file. Now here in the output, A, B as an input and C as output. You can see that for when the input was 0, B, one of the input was 0, A cannot be appeared there at the output as AND gate function. When B is 1, the A appears at the output. So this is with the simulation of VHDL program using Altera UP simulator. Thank you. So the last step is synthesis. We will be doing synthesis on Helium board, which we have got from IIT Bombay. So for that we need to go again to the Quartus 211. Now once you open a Quartus 211, now we have to go for open new project. It was in AND gate, and this way we opened a project. After opening the project, our next step is to open the VHDL file. So to open the VHDL file, again we need to click on file, then on open and say AND gate VHDL. So the file with .vhd extension will get open. It was on desktop and .vhd. So once we open that, the program will appear on window. Then we will go on tools. This is to assign the pin numbers. So we have chosen a device earlier. Now this is a print view of that device. So that max 3000A. So the pin configuration is in front of you. You can go to the IIT Bombay's folder there, which we got from their ePrayog website. Open the manual available there of a Helium board and the Helium version 1.1 user manual. This is the board, and these are the instructions. So in that instruction we wanted to do programming of the CPLD. So in the programming of the CPLD, there you can see that we need SVF file, and the pin numbers here also we can see. So we need that SVF files. Again you can see there the pin numbers. We require SVF file here like this, and the pin, as we said that we are using two inputs, so these are the pin numbers. We have to go with pin 4 as a switch 1 and pin 5 as a switch 2, and the output will be on LED 1 at pin number 24. So once we decide for that, we will again go back on our Altera pin assignment. Quartus 2 pin assignment, there we'll select pin 4 as input 1, we'll select pin 5 as input 2, and pin 24 as input as output, sorry. So this way. Now once we decide with the pin, we'll cut it. We'll again go back to generate the SVF file. For generation of a SVF file, before generating the SVF file, we'll compile once again the same compilation which we did in previous slides. So after assigning the pins, we have compiled it again. This process can be skipped if you don't want to continue with this, since we have already did it once. So for a better response, for a better result, I am compiling it again. So once done with the compilation, meanwhile I'll tell you that we are using here the Helium board made by IIT Bombay, and that has CPLD 3000A Max 3000A series. Okay, so compilation is successful. Now for generating that SVF file, we'll go in tools and programmer. So after going to tools and programmer, we will say that file, then create, we'll choose SVF file and we'll say okay. So it will take fraction of seconds of generating that. Once that SVF file is been created, we'll cut this. Now the SVF file will be saved in the same folder where earlier program were there. Now if you can see that, if you go to the desktop AND gate, and there you can see that in that folder we had a .svf file with the same as of S. This is here AND gate.svf. So we'll copy this and we'll paste it in the folder where we had UrJTAG. So we are going to IIT Bombay, UrJTAG, and here we will save it. So there is already AND gate SVF was there earlier. It might be because of earlier program. So I have to replace it again. I'll say that copy and replace. So the .svf file is already stored there. Now the next instructions we have to see it from the. Now we will run UrJTAG. So the JTAG is there for burning this thing in the, or for synthesizing VHDL codes on Altera, that Max 3000A CPLD. So we'll just see again the steps involved in doing it, the programming of the CPLD. It says we have to type a command cable FT2232. So we'll type a command as cable FT2232. Yeah, then enter. So it's a connected to, okay, so connected to LIBD2XX. Now the next thing we have to say as detect. So we type it as detect and then we put up a enter. So after running the next command, we got some instructions. Then next state is we have to indicate, or we have to indicate the .svf extension file, and that SVF is here. So we need to give exact path for .svf file. So we'll say SVF, and now we'll give the name, and I am able to give the name directly because I have copied down it to the same folder where the JTAG was mentioned. So that full detailed path is not at all required in mentioning here. I can just say as and.get.svf. Otherwise, if could have stored in the same program, I have to choose. So where it was, desktop AND gate. So this big path we need to mention, this IITB Crimton files, UrJTAG, and then AND gate. Since we copied it on the same folder, we need not to mention that, and we'll just say that whatever the file name was there, and we'll say it, and after burning it, it will run. And here now we can verify it on the board. So there I am making it as both are 0 0, there is no output. Now both are 1, there is output, like this. Thank you.